My name is Rene Schulte. I'm a lead UX developer for IdentityMind. I'm also a Microsoft MVP. I have a couple of open source projects as well, and one particular to mention is called Slot Toolkit, which is an AR toolkit version. So I have a background in 3D computer graphics, VR, AR, and those kind of things. I have also Laurent Bugnion with me.
Hello everyone, my name is Laurent Bugnion. Like Rene just said, I live in Zurich, Switzerland. I'm also a Microsoft MVP for Windows development. I'm also a Microsoft Regional Director and Xamarin MVP. And in the open source field, I have a project called MVVMI Toolkit, which you might have heard of if you do XAML development or Xamarin development. Our firm is called IdentityMind. We are located in Seattle, Washington, so physically and geographically very close from Microsoft. As well as historically, we have worked with Microsoft on Pixel Sense Stable. Back then they were called Surface, you might remember them. We have also worked on Kinect for Windows, Kinect for Xbox. So everything which is natural user interface, augmented reality, virtual reality, 3D, this is all something which is very natural to us. We are going to talk to you about the client scenario, and we work with Delta Airlines for their business launches. Business launches are very important for an airline because you have people going there, either professional or people with money, and so this is a class of passenger that you always want to attract and to please. So we developed this application to visualize flights. You might have seen an application on the web doing the same thing where you can see flights coming in an airport and out and all that. Here we have really added the third dimension because otherwise it's very difficult to see where is a plane in the vertical space, right? So this application can have multiple usages. For example, you can think of it, like I said, in a business launch. People are just waiting for their flight and want to be entertained by the traffic. Also, if you have a family coming in, you may want to see, okay, where are they now and when are they going to land and see what's happening with them. That's quite interesting. But we can even go further and think of the air traffic control scenario, where air traffic controller have a 2D information on the radar screen, and of course it's very difficult to see the vertical separation. Now those guys are professionals, they are used to it, but you know, nothing replaces a quick glance to a scene, a 3D scene, and then you will see immediately the vertical separation between the planes. So all those scenarios are interesting for our application here. We are going to show you a video which illustrates the application. A few notes about the video: it is not branded at the moment, it's a work in progress, but you can easily brand it, for example, for Delta Airlines, our partner. And also we are showing real-time data, so the flights coming in and out are real-time data, but we actually cache the data on an Azure backend so that we can also replay the data at various speeds if necessary. So I'm going to show the video now.
Welcome to HoloFlight, IdentityMind's flight visualization for HoloLens. When the user is gazing at an airplane, detailed flight information is shown, like the call sign, the origin and the destination airport, current speed, the plane type, and so on. When the user is double tapping on an airplane, ATC conversations is played back as spatial audio.
Well, let me talk to the other local. Maybe we could get you moving. I don't want to stop you right there, but hold short for right now.
You can see the Hawaiian Islands here and its surrounding flight space, with all the flights currently flying in that region. Gazing at an airport shows the wind speed and wind direction at that airport, and further detailed weather information can be shown for the airport, like the temperature and the temperature dew point. We also support variable wind direction, which is indicated by a quickly turning wind direction arrow. Our experience leverages HoloLens spatial mapping and spatial awareness of the environment, so the user is able to place all the different holograms independently in the room and lay out its workspace. We use HoloLens tap and hold or scroll gesture to allow the user to zoom into terrain to a different level of detail. For example, now the user is just seeing the island where Honolulu is located and can explore the area into more detail. Our experience also supports voice commands for zoom in and zoom out.
Zoom in. Zoom in.
At the highest level of detail, the user is basically at the tower control and can explore the flight space from this position.
Zoom out.
A list of all the flights can also be opened, and the user can select a flight directly from there. And it's highlighted in the 3D space, so the user can explore where it's actually located in 3D space, where it's flying to, see the flight trail, and so on.
Playback fast.
Our solution supports real-time but also pre-recorded data,
Playback max.
which allows us to play it back at different speed.
Sticky trails.
The sticky trails is a nice feature to visualize usually invisible information, so the user can see where the planes are actually flying between the airports and analyze those flight trails.
Clear trails. Playback normal.
The flight terrain can also be placed independently in the room where it fits well.
Scale up.
It can also be scaled up to fit the room even better.
Scale up. Playback insane.
The terrain is generated from real-world topographic data provided by the Bing Maps API. The actual flight data comes from a commercial flight data service provider, and we can visualize it in real time. But we also support our own custom Azure backend where we can cache the data to play it back at different speed. This gives us the unique opportunity to show usually invisible flight information like the flight trails, and we can also adapt the dynamic lighting of the scene to the time of the day.
Rene, do you want to take it over?
Yes. Another thing, this was a so-called mixed reality capture. So this is recorded directly on the HoloLens device and shows what the user is actually seeing.
No
So
simulation.
No simulation. Now onto the challenges we faced while implementing this. So first of all, when you visualize flight data, which is usually projected in 2D, when you bring it to the third dimension, it's also another dimension of errors. And we'll talk about this in a second. You want to show a lot of flight information, but you also have to make sure that you do not clutter the holographic frame with too much information. Right? The HoloLens has amazing sensors. It can scan the room. It can do this so-called spatial mapping of the environment, so it knows where it is in the room. And of course, you want to leverage that in your solution as well. But you have to make it in a smart way. And if you have those planes, small models, it can become hard to actually focus at them, to gaze at them. So you have to think about a good solution for this as well. And of course, you want to make it an awesome immersive experience, which is not just the visual aspect, but there's more to it, like Spatial Sound, for example. Yeah, flight data. First of all, you need to find good flight data, and there are a couple of providers out there, and we partnered with FlightStats because they provide a pretty good data quality and also reasonable price. And their API is a REST-based API providing JSON results, and everyone can parse that. That's nice. But then we noticed there are actually a couple of errors in the data we get. For example, you get a list of the last observed positions for each plane. And it can happen that you get for one position, which is reported by tower A, and the next position is reported by tower B. And it can be seen then that the plane is actually jumping. And this doesn't happen in the real world. We don't have wormholes on Earth, right? And another thing we noticed is from position A to position B at 180 degrees turning in courses, which would also not happen, otherwise no one would ever fly anymore. And then you want to visualize, so we spent quite some time to actually fix the data issues and have some data correction, extrapolation, and some smart algorithms to make it more meaningful. Then you want to visualize the data in 3D. So first of all, you have geographical coordinates, and you need to map it to an unwrapped planar rendering. Altitude mapping is also important. If you would map the altitude linear, like you would get it, you waste a lot of interesting rendering space with uninteresting flight information. So we do a nonlinear mapping of the altitude, meaning we give the lower ground space more rendering. So you see more of the interesting flights. We get the data almost in real time. And I say almost because there's actually a regulation, a governmental regulation in the US that flight data providers have to delay the data by a couple of minutes for security concerns, I guess. Makes sense. And then again, it can happen that you get the list of different positions for each flight. They can have different timestamps, and so we need to normalize them to actually have it nicely rendered all together. And then the right size for the planes. So you can see the planes are pretty small, and if you step further away, it just takes a few pixels. So what we do there is called level of detail. So we swap out the plane model with just a cube. You don't see the difference anyway. And we also make sure, even if you step further away, you can still see some pixels, so the cube stays at the same size. Yes, the UI is of course very important because you want to show a lot of flight information. But you also need to make sure that you're not like polluting the holographic frame with tons of information. So this was the first iteration, developer UI, it's like super ugly, right? And next version was this one with in-place billboards. So we basically showed at the airplane position, showed information, and you could enable it for a couple of airplanes, and you see the issue, it becomes quite messy with the overlays, stuff like that. So then we had those central curved screen UI. This curved screen UI was actually quite tricky to get right, there's nothing built in Unity, so we had to roll our own for this. But then we wanted to show more information in the frame, in the screen, like list of flights and so on. So this thing kept on growing, wasn't fitting so nice in the holographic frame. So we figured let's separate them into independent panels and polish it up so it looks nice. And what you have seen in the video is like you can pin those screens, those panels independently in the room and basically use the spatial mapping of the HoloLens and allow the user to lay out the workspace, if you will. Selecting objects is the gazing with HoloLens. And gazing is based on head rotation, and then a virtual ray is shooting out from your head, from the virtual camera, and where this ray hits the collision object, you know where the user is gazing, right? If you just take the same size for the collision volume as the plane, it can become quite hard to actually hit it, right? It will be very hard to select something. So what we do instead, we use a larger collision volume, and you can also think about to dynamically adapt the size of the collision volume. So if the user goes a bit closer, you can make it smaller, further away, a bit larger. Of course, to a certain min and max value. Yeah, spatial sound. Look at this. This is called a speaker night helmet. It might provide awesome immersive sound, I guess, but you actually don't need it. The HoloLens and these tiny speakers it has provide a very good immersive experience already. And in our solution, we use it to play back those air traffic control conversations.
Seabird 182 heavy, right Mike Alpha, right Bravo, then Papa.
And we do this at the position of the plane in 3D space, right? So even if you don't see the plane, you know immediately where to turn your head because your brain knows where the sound is coming from. This is the magic of the spatial sound. And if you have a use case in your solution for spatial sound, like we have with ATC conversation, it just makes sense, then I would encourage to use spatial sound. It's really another dimension of immersiveness. Yeah, some further best practices.
Yes, over the past few months we have worked with the HoloLens team, almost a year now. We have of course acquired a few best practices, so here are a few that we want to underline. And one of them is really to leverage animations to help your users. Animations are really a great way to help the user understand where he's located. So one example, for example, if you want to have a zoom into the mesh, and in that case we have here the video playing, so I'm going to zoom into the island of Oahu, and of course the zoom is without any transition, which is very disconcerting for the user because objects in reality don't appear out of thin air. And so with the HoloLens you're much closer to reality than on a 2D computer screen. So what you can do is instead try to do a crossfading, and that's already a little bit better. The transition is smoother, but there is still this problem that the user doesn't quite know what he's looking at. Okay? So again, animations are here to help your users. So what we do instead is a scaling and crossfading. So first we are going to scale into the mesh, and then we do the crossfading to the more detailed mesh. So like this the user doesn't lose the context. Okay? So even more important than in 2D, in 3D you really want to leverage those animations and be closer to real life. Rene, you have additional recommendations, I believe?
Yeah, a few. First of all, find a good designer and a 3D artist. You can be a very good 3D developer, but if you don't have good 3D models, you don't have anything to render, right? So we are happy at Untitled that we have a team of talented designers and 3D artists who can make also great models with a reasonable triangle and polygon count. And I say reasonable because HoloLens is a mobile device, which means you just don't have no full-blown desktop graphics card in this thing, right? So you have limited resources, and we noticed mostly it's fill rate bound, meaning you can render tens of thousands of triangles, but if the triangles or if the model is rendered closely and takes up a lot of pixels and you have a very intense pixel shading, which runs for each pixel, it can bring down the performance quite fast. So don't use that. Use simple pixel shaders. Actually, for most things, vertex lighting works just well. So, which is way easier, and yeah, no screen space effects like ambient occlusion and those things. It's just too heavy. Because you want to stay with 60 frames per second. You don't want that your experience drops to 30 frames per second or lower, because this can actually make your users sick. The holograms start to drift, they cannot keep up with the movement, and users can actually get headaches and stuff like that. So it's something you don't want your user to experience in most cases. In most cases. HoloLens has a multiple CPU, and in HoloFlight we actually do the whole background, the data fetching, pausing and so on in a background thread, so the UI thread is free from the work and can keep up with the rendering loop. Yeah, gazing is important. So gazing is based on so-called inertial measurement unit, the head rotation basically. And like every sensor in the world, sensors provide noisy data, right? And you want to smooth that noisy data, because otherwise when you visualize the gaze cursor is jittering, which is not nice. The Holo toolkit, which was also released, already has a smoothing algorithm you can just apply. We actually use our own smoothing algorithm because it gave us a bit better results, but regardless which one you use, just make sure to smooth the gazing good. If you have multiple Unity projects, you will probably have some reusable scripts, which is a pain in the ass, right? So, and you want to have a maintenance, a nice maintainable solution. So what we do, we have a C# solution where we have all the reusable scripts in one central place, some post-build steps which copies the DLLs into the Unity assets plugins folder. So it's in all the projects the same stuff, and it's really easy to maintain. Unity's biggest benefit, in my opinion, is what you see is what you get editing. You have the nice editor, you can try out some changes on the fly. But if you want to test like gazing and gestures, you have to deploy it to the device or to the HoloLens emulator, which takes time. So we have a custom script where it can actually simulate the gazing with the mouse and a couple of gestures also. So we can stay most of the time in Unity and be very productive there. But then again, you also want to test it with the emulator, because the emulator also supports speech recognition. You can load different spatial mappings, you can load spatial rooms with it. But in the end, you also want to test on a real device, because for performance reasons and so on. Nothing comes as close to the device than the device. Yeah, time for some conclusions. It's a great time to be a developer again. You can even run your 2D, your Universal Windows Platform applications will also run in HoloLens, but those will run in a 2D. They will run in a window basically. And in a mixed reality environment, you probably want to have 3D content. And you can do 3D content for HoloLens with Direct 3D, either with C++ or C# via SharpDX. Or you can use a middleware like Unity, which takes away a bit of the burden, and you don't need to deal with all the math, if you will, but still you need to be familiar with certain concepts of math.
Yeah, in fact, like Rene said, great time to be a developer. Those devices used to be science fiction, but now we finally have them, and they are actually relatively easy to code for, so the level of entry is not that high. I really encourage you to go and download the HoloLens SDK. It was available since yesterday. There is a very good emulator in that. It's free. The emulator is helping you to get started, even if you didn't get a device yet. The slides are going to be available at this location, as well as the embedded videos. And finally, the recording of the presentation will be available, I believe, probably next week or the week after that on the HoloLens Academy website. We don't have much time for questions, but I encourage you to come to us after that, because we have to clear for the next speaker, okay? Come find us, or if you don't want to come find us in person, you can talk to us on Twitter. That works too. All right, thank you very much for your attention, and I wish you a happy end of the conference. Thank you.
Thanks a lot.